So let us recall what we have did in the previous lecture. If you have X, which is a metric space, and A is a closed subset of X. If you want to say that a set A is a closed set, if A is a closed, if it contains all its limit points. What is the definition of a limit points? If you want to say a point X, which is a limit point of the set A, if for every neighborhood of X except that point, intersection with A will be non-empty. And then we have proved that empty set and the whole set X are always a closed set. If A is a closed set, if and only if its complement will be open. So this is the relation between the open set and closed set that we have established in our previous lecture. The next things we have proved that the closed sphere, where R is a positive number and X0 is any element in X, then we can define a closed sphere as set of all points such that all points in X such that distance between X and X0 is less than or equal to R is a closed set that we have proved in the previous lecture. And the next we have proved that arbitrary intersection of a closed set is always a closed set. That is very important results. We have proved that any intersection or any arbitrary intersection of a closed set is closed. And one more result we have did is any finite union of closed set is a closed. So finite union of a closed set is a closed, and arbitrary intersection of a closed set is also closed. That we have also proved in the previous lecture. Now let us discuss what we have next. So as we have discussed about the interior of a set, we also have the definition of closure of a set. So can anybody try to define what you mean by closure of a set? That means if you have given one room, when I can say that room is, now a room means a set of all points which are having a room. When I can say that room is closed or closure of, what will be the closure of that room? So the idea is the points which are inside as well as they forms a closed thing. So what will forms a closed thing? Its limit points. So the closure of a set is actually a union of a set and its limit point. So for that we required first of all a metric space. Let X be an X be a metric space, and A is a subset of X. The closure of the set, closure of A is denoted by, there are many notations are used for the closure. We will use this notation A bar, and is the union of A and the set of all limit points of A. So that means A closure will be A union D of A. A D of A we have defined as the set of all limit point of A. For example, if I have a set A is open interval 0, 1 and your X is R with the usual metric space, then what will be the closure of this set? So it is A union its limit points, set of all limit points. The A its open interval 0, 1 union. What are the limit points of closed interval 0, 1, which we already discussed in our previous lecture? It will be a closed interval 0, 1. So the union of this two set will gives you closed interval 0, 1. So the closure of open interval 0, 1 will be a closed interval 0, 1. Let's have the another example. Let us consider X as a set of all complex number with usual metric, and A, if I define a set of all complex numbers such that mode of Z is less than 1. That means I have taken a unit disk here. What will be the closure of this set? Can somebody tell me? So that means it is A union a limit points of A. A is already there. What are the limit points of this set? So you just see, let us try to draw that figure. So this is your X axis and Y axis. What is this mode Z less than 1 represent? This is represent one disk which does not include its boundary. So it will having the inside portion of this yellow part is represented by the set A. Now what are the limit points of this set? So if you pick up any point outside this set, if I am able to draw a neighborhood of that which does not having the intersection with the set A, and we can able to do that. So this any point which is mode Z greater than 1 will not be a limit point of that. What will happen if I pick up a point on this equal to? That means if I have a mode Z equal to 1, if the point is satisfying this property, then if I am able to draw a neighborhood of that, and this intersection is always having some intersection with the set A. That means any point on this mode Z equal to 1 will be a limit point of the set. What will happen to the inside point? Inside, it's always having the intersection with the set A. So that's why the limit point of this sets are the set of all points such that mode of Z is less than or equal to 1. So this is that gives you that set of all Z complex number mode Z is less than or equal to 1 is the closure of this set A. That gives you third example. If I consider X is R with the usual metric, and if I have A which is the set of all points which is of the form 1 plus 1 by 3 up to so on, what will be the closure of the set? Now tell me the limit points of this set we already discussed in our previous lecture. So now I want the answer from you guys. What will be the closure of this set?
So 0, 1, 1 upon 2, 1 upon 3 and so
Yeah,
on.
0, 1, 1 by 2, 1 by 3 and so on. So this will be the closure of the set. Okay, I'm giving you some examples to do it yourself. You can write down what will be the closure of the natural number n. You may write the closure of the set of all integers. You may write what is the closure of q, what is the closure of q complement. So there are as a subset of R, okay, with usual metric, that you can write down what are the answer for this yourself. Now, one more things you can note here is this A is always a subset of A closure, because by the definition we know that A closure is a union of A and its limit point. So this A closure is always a superset of A. And also we know that A interior is always a subset of A, and so from this what we can get is A closure will be a subset of A and will be a subset of A closure. So A interior, so this is the relation we always have for any metric space is there as a subset. So for any A as a subset of a metric space, which we got this is as a relation. Now the next definition that we are discussing about the boundary points. So this is the next definition. Can somebody try to give the definition of a boundary point? Now think of the same thing as we are discussing. We are sitting on a room. When I can say a wall surrounded by me will be a boundary of this room. So what is your idea to define a boundary point?
Sir, every epsilon neighborhood should contain a point from A and also a point from A complement.
Very good. So yes, definitely that should be the boundary of the set, because when you pick up any point on the wall, and if you try to draw a neighborhood of that, that neighborhood should intersect both A and its complement. So then we can say that that point is a boundary point of the set. So how we can define a boundary point in the same manner? That means I want the first of all a metric space X, let X be a metric space, and A is a subset of X. A point X0 in X, it's called a boundary point of A if each open sphere center at X0 intersection of both A and A complement, or by notation form we can write down this is as for each positive real number R, it will satisfy SR of X 0 intersection with A is non-empty, and SR of X0 intersection with A complement will be non-empty. So it is the situation where that you have a point which is, so you have a point, if you trying to draw any neighborhood of that point, will have always intersection with A and its complement, then that point is called the boundary point. The next definition is the boundary of a set. So what should be the definition of a boundary of a set? Is the set of all boundary points A, it's called boundary of a set. So there is a difference, vast difference between a limit point and a boundary point. Okay, because in the previous examples, that also you can see. For example, let's say example, I have a x is equal to r and A is open interval 0, 1. Then what are the boundary points of this set A? We should note here the boundary points or boundary of a set A is denoted as BDR of A. This is the notation for denoting a set of all boundary points. So I am talking about what are the boundary points of this set A. You just look at it.
0 and
Yes, not heard.
0 and 1.
0 and 1. So you have the open interval 0 and 1. Now, what is the boundary point as per the definition? For any neighborhood, it has to be an intersection with A and its complement. So if I pick up any point here outside this, then it will have an intersection with complement but not with A. So this point, any point which are outside, any point on this side over on this side will not be a limit point. If I pick up the point inside this interval, then also having the intersection with A but not with the complement. Yeah, but if I pick up the point as a 0, then and if I draw any neighborhood of this 0, then always having the intersection with complement also with the A. So that's why 0 is a limit point of this set A. And same argument can be given with 1. So that's why the boundary points of this A are 0 and 1 only. So there is a difference between limit points and the boundary point. Limit point of this set A is close interval 0, 1. Okay. The boundary points is different than the limit point. So that is first you should know. The same. Now what is the limit point of this set? A is equal to 1 by 2, 1 by 3 up to so on. What is the limit point of? What are the limit points of this set? Let's think for this. What are the limit points of this set? So as per the argument, if this is 0, if this is 1, this will be 1 by 2, 1 by 3 maybe here, and so on. If I pick up any point here, draw a neighborhood, will not having the intersection with A. If I have a point here, then also we have the same situation. If I have a point A, then that is also not there for point. This one will also not there. What about 0? If I have pick up a neighborhood of 0, which having the intersection, any neighborhood of 0 having the intersection with A always, but will it be intersection with A complement? What is A complement? A points which are other than this. Any neighborhood of 0 will contain some points of this. Also its complement, yes or no?
Yes, sir.
Yeah, so what are the boundary points of this set A? Only singleton 0. They are the boundary point of this set. In that same manner, you can able to find out what are the boundary points of other sets if it is given. For example, If I have given you x is equal to set of all complex number, and A if I define a set of all complex numbers such that mode of Z is less than 1. What are the boundary point of this set? That means what is BDR of A? Yes,
Mod Z equal to 1.
mode Z equal to 1. So set of all points in C such that mode Z equal to 1. I'm not giving the argument, you can think for that why this will be there. Okay, fine. Now the next very important concept, let me gives you, let me do it. I think